Balancing equations. So again, this is one of those important skills that come up time and time again in chemistry, because if you don't have a balanced equation, you can't do any calculation. Okay. If you're watching this at the beginning of Unit 1, you might think you don't need to do any, but they will come. So there's a few steps that you've got to follow. Step 1, write the unbalanced equation. Okay. What's really important is that you get the chemical formula for all reactants, okay, and you get those chemical formulas correct, and the chemical formula for all products correct. If you're not sure how to do that, go back to the writing formulas video. Okay. There must be an arrow between your reactant and your products, not an equal sign. Equals means they are the same. Arrow means it becomes. Also be careful when you're putting them in of your diatomic gases. Now there are 7 diatomic gases. They start at number 7 on the periodic table, which is nitrogen, and they go across to oxygen, across to fluorine, and then down to iodine, making the shape of a 7, plus hydrogen. Yeah, it doesn't fit the pattern. But if you remember, start at number 7 and make the shape of a 7, you'll be pretty good. They're diatomic because they go around in pairs. So you don't just get H, you get H2, or F2, or Br2. Then we've got to balance it. Now when we're balancing, we remember that we can't create or destroy matter. We also can't perform alchemy, changing one type of atom into another. What we do is we change how they're arranged. So we've got to have the same number of each type of atom on the left and the right of the equation. You're not allowed to change the formulas that you've just very carefully written. The only thing you can do when you're balancing equations is add coefficients to the front. Okay, so these are our formulas. I checked for my diatomics, I recognised oxygen was diatomic, so I put that in as O2. So I've got methane, the gas that comes out of your gas taps, burning to make carbon dioxide and water. At the moment, my carbon's fine, I've got one of each on either side, but my hydrogen and my oxygen are not. So here, this is a coefficient. I'm adding a 2 in front of H2O, and that's going to make my hydrogen balanced, but my oxygen still unbalanced. Okay? At the moment, I've got 2 oxygens on the left, and I've got 4 on the right. So I'm going to add another coefficient, 2 in front of the oxygen, to make a fully balanced equation. Similarly, here's a precipitation reaction. I've got silver nitrate and calcium sulfate, and I'm going to make silver sulfate and calcium nitrate. At the moment, the silver, the nitrogen, and the oxygen are unbalanced. Now here, because I've got a polyatomic ion, nitrate, and another one, sulfate, I'm going to count them together as the ions. I'm not going to count them as separate elements. Just makes it easier. So if they stay as nitrate on the left and the right, then I'm going to keep them that way. The only thing I need to do to balance this, therefore, is put a big 2 in front of the silver nitrate, which gives me 2 silvers and 2 nitrates, and makes everything balanced.